Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So I want to do something a bit different this week. Call it a side quest to 3D printing. Now, we're going to be doing a bunch of stuff with 3D printing as well, and in fact, I've gone ahead and ahead of time printed out a whole bunch of samples of different types of material 3D printed to test, and we're going to be doing some design in 3D printing for some jigs to hold some of this stuff as well. But many of you have reached out and said, hey Rich, when are we finally going to get to take a look at that xTool F1 Ultra dual laser that xTool sent out before I went in for surgery on my arm and my wrist? And I think the arm's finally doing well enough to start playing with that machine. So I've got a bunch of stuff lined up here to test in a bit of an unorthodox way. And what I mean by that is xTool sent out a whole bunch of stuff to try with that machine. There is like leather and a couple different metals in here. And then they also sent this out with a bunch of other different pieces of jewelry and different things that you could try engraving on. Actually, that looks like, oh, that might be useful. That is, I think, stainless steel and brass. Well, we might actually use that. But I don't want to look at that stuff because you know what? There's probably 75 other review videos that are already testing that stuff. This is a 3D printing channel. First and foremost, I want to see how the laser actually works and marks or doesn't mark all different types of 3D printed material. Let's see, we've got a bunch of different colors of PLA. This is the petg HF from Bamboo. More colors of PLA, that's Sunlu. This is ABS. We have some regular petg. This is more PLA, TPU, and some other regular petg in another different color, red. So we're going to try out if we're able to mark and or maybe engrave all these different types of materials, but I got a bunch of other stuff here that I want to do as well. You guys, if you already watched this channel in the past, you know that I tend to focus on more of the functional use of things versus the more sort of decorative, make a cool trinket type thing. So I've got a bunch of stuff here actually that I'd like to try getting done with this machine. Let's start with this guy. This is, I've had this knife forever. This is a Wüsthof knife. And a long time ago, the logos came off of it. Here on either side in this little sort of round section, there should be a Wüsthof logo. I'd like to try engraving the logo back in there. This is stainless steel. I don't want to just make a mark on it. I'd actually kind of like to have it, you know, engraved in there a little bit. So we'll try that. Let's see, what else? I've got, oh, this will be interesting. So I printed out just a real small HueForge. You guys have probably seen these before. This one is not particularly detailed because it is so small. But I wondered if maybe we could sort of melt just the surface of the material without changing the color to give this an even cooler look. If you've ever looked at these really close, you can kind of see where the filament's actually laid down. And it works, the way this works is by blending the different colors together. Like this is solid black here. This is one layer of orange over top of the solid black. That's probably 2 layers. And then where the orange is the brightest is like 3 or more layers of the orange. So I thought it'd be kind of cool to see if we could sort of remelt just the surface of this to blend it back together a bit. So we'll try that. I have a VIN sticker from my trailer. Yes, the VIN plate was actually just a sticker, and part of it came off last time I pressure washed it. I think this is the only piece that's missing. So we'll go up, we'll take a look at that and see if we can reproduce the VIN plate for the trailer. That's actually what this aluminum stock down here is for. This is probably way thicker than I need, but it is the right width. And yeah, I think the whole VIN sticker itself is probably about that long. I'll have to get a picture of the remaining part that's on the trailer. And I'm hoping to, again, engrave that, not just mark this material, but engrave it with some depth so that the VIN plate actually lasts longer than, I don't know, a couple of years without coming off. What else? Oh, this is a piece of 1 millimeter thick solid brass. I'd like to try making a gear with this. If you've ever seen like those very small gears that you'd have on like a clock, not so small like you'd have on like a pocket watch, although I guess we could try and make one that small too. I'm thinking maybe the size gear and tooth count that you'd have on like a wall clock. Those are really hard to machine, and I'm wondering if we couldn't just kind of carve ourselves out one from a solid piece of brass on the machine. So we'll try that. This long piece of wood, I want to try and make just a sign out of it. Now, I know that doesn't sound that interesting, but I think we could actually make a sign this whole length on this machine, even though this is a galvo machine, which would normally be limited to a really small work area. There's actually a conveyor belt that comes with this machine. Well, it comes with it depending on the package you buy. They sent me one. I have it. I'd like to test it. And as I understand, the conveyor belt will move back and forth and actually allow you to engrave much longer objects than you'd be able to do with a galvo machine, or probably even larger than you could do with like a large bed diode or CO2 laser. So I don't know if we're going to get to that today, because honestly I don't know that I can set up the conveyor belt with my arm yet. So this might be a future video. I've got two collets here. The reason I have two is because if you look, this one is marked. So this is an R8 collet. This is for my milling machine, and this is a 1/8. I got this one at some point, probably at an estate sale or something, and there's no markings on it. So, I mean, I can measure it. I can figure out what size this is, but because it's not marked, every time I'm going through my collets looking for the size that's going to be the right fit, yeah, I always have to measure this guy again or do a test fit with the shaft of whatever I want to chuck up in the milling machine. So I'd like to actually engrave the face of this with R8, the type of collet that it is, and the actual size of the collet. This is going to be really hard steel. This is tool steel. This looks like an older collet, so it's probably a really nice tool steel, actually. So this is going to be a challenge, I think, to engrave, but I want to try doing that. I got a piece of aluminum here. I kind of want to just see what we can do to the surface of this with that machine. We should have no problem marking aluminum, and we're going to do that with a VIN plate anyway, but we might try something a little bit deeper with this. This is just an ordinary piece of, I believe it is mild steel. And if you look at this face of it, you can see that as just a machined finish. In fact, actually, I'm just noticing there's like sort of a lip on either side. It looks like, I found this in a pile of just junk pieces of steel. Again, probably in an estate sale or something else. But I grabbed this one because this has this just sort of milled finish on the top. And there's nothing wrong with that, but it's also not particularly attractive. And I was thinking the other day, I wonder if we could actually ablate away just the top surface of, say, a machined part to give it a much more uniform finish. Like typically what you'd do is you'd either grind this to give it a nice finish, a ground finish, or you could put it into a machine that turns it over with other parts and an abrasive to give this kind of like a brushed finish on the top. I'd like to try and see if we can do that with a laser. I think that might be a neat way to get a much more consistent surface finish, without, say, a surface grinder. So we'll try that. Let's see, what else? Oh, I've got, these are just regular bubble envelopes. I'd like to see if we could mark the surface of this, maybe put a logo on this. Particularly, galvo lasers are really fast. So while there's certainly plenty of other ways to mark this packaging, like if you wanted to put a brand logo or something on it, because a galvo laser is so fast, if we could just quickly pop this down, hit a button, and it would mark this in a matter of a second or two, that could actually be a viable way of marking these. And same thing with cardboard. I grabbed just two empty boxes here to see if we could mark the cardboard. The trick there on either one of these is going to be marking them without damaging it. I don't think the cardboard's going to be too hard. These might be tricky because it's a thin layer of paper before we get to just sort of the bulk of it, which is this plastic material inside. And this guy here is a battery pack out of a Bluetooth speaker that I probably should have just thrown out, but I struggle with throwing things out if I think I can fix them. And this battery pack is no good. And they sell replacement battery packs, but they're like 20 bucks and I'm cheap. And I've got plenty of these size batteries to make another pack from. And if you look at these, the way these packs are made, I think this is stainless steel, and it is spot welded onto the terminals of the batteries. And they're spot welded because you want to weld the tabs on in such a fashion that does not heat up the battery, that doesn't heat up the cell itself, that the heat is limited to just where the terminal is. Now these are generally done with force and contact, so like an electrode will push down on this and they'll run a lot of current through it and it'll arc and spot weld that. I'm kind of wondering if we can do the same thing with a fiber laser. This one I think is going to be a stretch just because I'm not even sure how we would hold the tab down. Like I think we might need some mechanical force to hold it tight against the battery to duplicate these spot welds. But yeah, I'm thinking to test, what I'll do is maybe we'll just pull off this tab and see if we can weld the tab back on in another spot just as a proof of concept. All right, before we get into all that testing, let me introduce you to the machine. So this is the xTool F1 Ultra. And xTool did supply this to the channel completely free of charge for us to try out on marking functional prints. And honestly, whatever else we want to do with the machine. They're not paying me anything to make this video. They're not sponsoring the video in any other fashion. They haven't provided me anything else. They're not seeing this video before you guys are seeing it. They haven't asked me to do or say anything. All of my thoughts and opinions will be my own, but I do want to just share with you guys. They did send it out free of charge. I think it's important to disclose that. Okay, so initial impressions before we even do anything with this machine is it's honestly really compact for the size of the work area. It's a lot smaller than I expected it to be. And I don't mean smaller in what the machine will do. I mean smaller in just the physical size that it takes up on a desk or a shelf or wherever you put this. The work area on this machine is 220 by 220, and that is almost the whole size of this base area down here. There's really not a lot of space wasted. Yeah, there's some depth back here, but not much. And the lasers, yes, I said lasers, plural, are up here on the top. This is both a fiber laser and a diode laser. They're both galvo, which means they're both, the beam of the laser in both cases is steered around by an X and Y mirror, so they're very fast. But yeah, I couldn't believe how small the footprint is of space that this machine actually takes up. It's got a control panel on it. I'm not sure how useful that's really going to be because I think we're going to need the software on a laptop to run it anyway, but this is probably useful if you are just have a number of like saved designs that you are executing, repetitively. Like if you have, I don't know, maybe you do like a set of coasters or tags or something, and you just want to recall that job and run it. I imagine it's probably useful for that, but we'll see. I haven't really had the opportunity to use it yet. In fact, if we click last project, there is none because I have not used this machine yet. I've got it all set to go, but I have not even connected it to the laptop yet. The other thing that stands out right away is the design of the machine. You saw me lift and lower this before. This is actually on like a track over here on the side. It's not actually attached to this top part. That moves independently to focus the laser. It's attached to this part back here. And it makes it so that you can close this and the machine is safe to use without laser safety glasses for anyone in the room. That's really cool. It's been a big criticism of mine for other competitive machines that by default just don't have any safety whatsoever. They anticipate that anyone in the same room with the machine is going to be wearing laser safety glasses at all times. That's just not practical. Say you have this machine in your office and you've got your laser safety glasses on, but somebody else comes into the room, your kid, significant other, whatever. Are they wearing safety glasses, laser safety glasses? Probably not. Now, will it work if it's not closed all the way? I don't know. We're going to find out. Like, what if we have a longer piece of something that we just want to engrave the center? Is there an interlock that keeps this from working? I can't imagine there is. Maybe there's just something we bypass so that we can bring this down on a larger object, but we'll find out. Also, fume extraction. You can get this machine without the fume extraction. It still has the hookup port on the back, either to vent outside or to use, some other type of fume extraction system. The fact that they've even just built that in and it has a fan and intake built in right in the back of the chamber here is a huge step forward from so many of the other machines out there that don't consider anything from a fume extraction perspective either. I mean, basically, most of the lasers that I've seen for sale assume that you're going to stick the thing under a fume hood and wear safety glasses before you even enter the room. That's a lot of assumptions to make, but hey, it saves them money. All right, here's what I'm talking about. Here's the remaining part of the VIN tag. You can see the missing piece. Does it line up? Yes, that does line up. That's good. So we're not missing any parts. So I can scan this part. I'll have to take a picture of this with my phone just to kind of as straight on as I can. All right, let's go down and, well, I'm going to get some pictures. I'll see if I can get this sort of put back together into one image in Photoshop, and I'll bring you guys back. All right, here's the picture I took up at the trailer, and I tried to shoot this as straight on as I could. Turns out I still had a little bit of perspective in it that I had to correct, and then I scanned in the portion of the tag that had fallen completely off. Combined those two together, you can actually see here, I can turn off the layer for the rightmost portion of the sticker. There's the left section, and you can see if I turn on this touch-ups layer, I just went in and just cleaned up just sort of the crack, the section where the sticker pulled apart. and corrected the perspective on this as best as I could. It's not perfect, but that's fine. I know I could type all this in over again, but I really wanted it to be exactly the same as the original VinTag, just in a different format, an actual piece of aluminum as opposed to a sticker. So I'm gonna save this as a high quality JPEG, and then I'm gonna import it into the xTool Creative Suite. I'll do a trace on it, and let's get started on this. All right, and here's that finished VIN plate, and it came out really, really nice. And I did nothing to prep this aluminum at all. I left it completely just right, the same as it was right out of the stockpile, because it's not like this thing is gonna be, you know, on a desk or mounted to a wall. I mean, this is gonna be outside on a trailer that gets used and abused. So this is gonna have things knocking into it. You know, it's not going to stay, you know, I could wire brush this whole surface, I could steel wool it, I could sand it, and would have a much nicer, consistent surface finish, but it's not going to stay that way. So I figured, why bother? So I engraved it exactly as is, just as a raw chunk of aluminum out of my stockpile. And it looks really good. There's probably about 60 passes on here, and I think that achieved a depth somewhere between maybe 0.3 and 0.5 millimeters. Should be plenty deep that even stuff getting knocked into this is not going to take off enough of the base material on the top to get down anywhere near that lettering. So yeah, very happy with that. All right, unfortunately, I think we're going to have to give up on the gear. This started off looking really, really promising. And I mean, it still does. And I think we'd eventually get through there, but I've got probably 1,500, maybe 2,000 passes on this. I've actually lost count. And progress seems to have slowed down. I think the width of the kerf starts to become an issue. I did actually lower the head down a bit, but yeah, I mean, it's definitely very accurate. It's just this material is too thick. And I mean, to be fair, I kind of knew that going in. I think this is 1 millimeter thick material. xTool lists the capability of this machine at 0.5 millimeter material. So again, I think we'd eventually make it through. Certainly not quickly. I mean, this was running for a couple of hours, maybe 2 hours total. So yeah, I mean, if you've got all day and this is the only machine to do it, I think you'd eventually be able to do it. But yeah, I would stick to probably the 0.5 millimeter thickness that xTool specifies. I also went kind of bigger with this than I originally planned. I was thinking half this size, and when I ran the first pass, I saw the size, and I'm like, yeah, that's kind of bigger than I was expecting. We might have gotten there if I did this at half the size, but yeah. All right, let's try the knife. All right, I've got the knife in here, and the reason for the blue tape is just to keep this guy from moving around at all. Every surface on here is curved on the knife, so you set it down on a flat surface and it just wants to swing around super easy. Like even just bumping the table a little bit, it was swinging a couple degrees. So that should keep it in place for us. I've already set the height of the laser. That's one touch in the software in the xTool Creative Suite. It actually will raise and lower the head and find the focus point that is underneath your 2 laser points. So that's already been done. But this machine also has a camera up inside the head. And it's really sweet for this type of work because we could try and figure out exactly where that is in the coordinate system or even use the framing function. But being able to see the image of the knife here on the bed of the machine, I'm going to be able to bring this logo down into place, get it to the correct size, and rotate it to the position I want before I even go to the framing stage. So I just grabbed, this is the Wüsthof logo, SVG of it, I just grabbed from online. But I'm going to bring this down, get this centered in the right position, and let's see if we can engrave this. I believe this knife handle is solid stainless steel, so we're going to go with that setting. All right, I've got it centered up in there, I've got it rotated the way I want, and I have framing turned on, and it looks like we are in the correct position. So I guess at this point there's nothing left to do but go for it. That looks really good. Looks like we are centered in the spot. I'm going to give it maybe 10 passes and see what it looks like. Yeah, that's looking really good. It's hard to see how much depth we have. I don't want to underdo it because I'll never get it centered back up in there right. I think I'm going to do I think I'm going to do 10 more passes. And what I'll do is I'll leave the cover open this time. Just make sure that I lock the doors here to the shop and get my glasses on. Hopefully you guys get a better view of this. It's really cool to watch it, and I don't know how good the video is coming through through the cover. All right, let's get this off of here. We're going to have to flip it around and do the other side, but I also want to get a closer look at it. Oh, wow. Yeah, that looks really good. I'd say that is much better than the original plastic logo that was glued on in that spot. All right, that looks pretty much just the same as the other side, I believe. Yeah, that worked. That worked great. All right, let's test with our 3D printed material. And I was going through the box of stuff that came with this machine, and there's a little piece here that I believe is designed to mount on the table directly so that we can get consistent alignment with a part like this. So let me find the best position to put this on the table so that all these get marked in the same way. Okay, so in the xTool Creative Space, there is an option for material test array. I've generated one. It only seems to let me tweak the power and the speed. So I'm going to go from 10% to 80% on the power, and speed, I believe I'm at 1,000 to 10,000. And I've got the frequency set at 50 kilohertz since I can't adjust that in the test array. 50 kilohertz, based on my experience with engraving 3D printed plastics on a different fiber laser, should get us in the right ballpark. And we can see what effect speed and power is going to have with this machine for all these different materials. I'm going to start off with the petg HF only because I know these settings for sure are going to work on that, but we're going to run these exact same settings on every piece of material. I'm just going to swap the piece of material in, take the sticky note off, run the job, put the sticky note back on, and put it back in a pile. So we'll run all of these with the exact same settings, and then we can compare the results when we're done and just see how this machine did for marking all these different types of materials. Okay, so I had that on score instead of engrave. I meant to have it on engrave. I don't want to just, sort of mark the outlines of those squares. I want them to be filled in. So I redid the settings. I'm going to flip this one over, which isn't ideal because this actually has some marking on the back, and this is a different texture. But that's okay. I mean, this one, I already know what good settings are for this, and I knew this would mark well. Again, this is the petg HF from Bamboo. But I'm going to flip it over and do it again with the correct settings for engrave and just make sure that we're good before I move to the next piece of material. All right, and that's the result I was looking for. You can see here on the slower settings with the higher power, it really is just melting the material. But I think we're going to see some variability there because I think the colors of this material are going to change how much of the light from the fiber laser is actually absorbed in the material. So, all right, I'm going to run the rest of the samples with these settings. All right, this whole stack is now done, and we'll look at these in the reverse order in which they were marked, because that's how I stacked them back up. And the top one is the SainSmart TPU, and there is almost no marks on this. Tiny bit, I don't know if the camera's picking it up. There is a tiny bit of marking on the highest power settings and the slowest speed, but yeah, not much at all. I don't know if this is just translucent to the laser or what, but I was kind of expecting this, since it's black and our other black samples were marked so dark, to do something. But yeah, TPU seems, at least with the settings that I tried, almost unmarkable. This is a really interesting result. This is actually one of my favorites. This is the TTY3D Silk Shiny Copper. And I like this one so much because we actually kind of got different colors on it. I think that is I wish I had some other silk filaments to test. I don't think I do. But look at that. That is a really, really neat look. Very faint markings up here to what looks like almost kind of like a whitish orange to a really deep, darker colored orange or copper color to what the material is. That's probably my favorite result out of the stack. Let's see, this is Bamboo Lab Basic PLA in green. This one was difficult to mark, I'm guessing because of the color, and even where we did mark it at a fairly high power, I wouldn't say it's a really great result. It's kind of rough, it's not very consistent. If you had to do it, you could do it, and maybe if we slowed down even more, we'd get a darker mark, but yeah, that one was tough to mark. Okay, this one is Sunlu plain old regular PETG. This is not like the high flow stuff. This is just plain old, OG PETG. And yeah, great results on that. You see we have a range of different colors we could hit, to very, very faint marking here to a really, really nice high contrast, almost white mark, to darker marks here. And then as the power ramped up, we really just kind of started melting that. It would be interesting to go over this again on the sections that are melted with a power setting more akin to the center here, to see if we could get kind of a smoothed, recessed effect with the lighter color. I might try that at a future date. All right, next up is this is Hatchbox ABS, and this one marked pretty well. It did melt quite badly. I'm going to speed the video up of marking these. I think it took almost 30 minutes to go through the whole stack. This one was smoking quite a bit, and it did have that acrid ABS smell even after coming through the filter. Very faint. The filter did get most of it, but this smoked a lot. And you can see how melted these are. Decent mark up here through the middle of the range. I mean, if I had to mark text on this, I could definitely do it, but it wouldn't be my first choice. PETG marks a lot better. All right, this is Sunlu's high-speed PLA in orange, and the marking is very faint, but it did come out nice. If you had to mark it, you could. It just wouldn't be real high contrast, but I kind of figured that on such a bright orange color. And maybe if we slowed this down a little bit more, we'd get a little bit of a darker mark, but you can see out here in the faster speeds and the lower power settings, it didn't do anything at all. I think it just reflected the majority of the light. All right, this is Hatchbox PLA in white, and kind of the same thing on the higher speed and lower power settings, nothing. Like no marks whatsoever. But as we got into the higher power and the lower speeds, we did mark it. The contrast is not very good. Maybe if we slowed it down even more, but even down here, it's kind of starting to melt a bit. I think it's a combination of melting and burning, and that's why we have a little bit of an almost charred look. I mean, it's on there, it's stable. I'm not rubbing it off, but yeah, not the best mark on white. All right, this is CC3D PETG, and this one also smoked quite a bit on the higher power settings, but if we get into the second row, I don't think it was smoking much, say, on that setting there. That would be, let's see, I think that would be about 70%. I have to look up the numbers from one of the ones that we got the nice good grid lines on. Unfortunately, there wasn't a consistent setting that would get me grid lines on all these different materials for the test markings here. But the red PETG, definitely doable. You don't have quite the range. You go from a dark mark to melting the material fairly quickly. Okay, this one is really interesting. This is Hatchbox PLA in gray, and we have a really nice range of marks on this in comparison to the white. Just the pigment in here, the additional pigment going from the white to the gray. If I grab the white one out of here again, you can see the stark difference in these. This is definitely usable marks. I would say this is probably the lightest material you could go with and still get really good high contrast marks on. Would be this Hatchbox PLA in gray. And even down here, it's almost, I don't know if the camera is picking it up. At the highest power settings and the slowest speed, it is a super smooth, glossy engraving. It almost looks like it's painted. I can't tell on the camera screen if it's picking it up as good as my eyes are, but that is gorgeous. As far as quality of marking, that is probably the nicest one out of the bunch. It truly looks like white, like smooth white paint on the surface of the material. Let's see, we got two more. I got a little bit out of order here. This is the Hatchbox PLA in blue. Not the best. Even down here at the highest power setting, it's just not consistent. You could do it if you had to. I would go right to whatever the highest power setting your machine is and slow it down and just try a couple tests from there. And you could see down here as we either got out of the slow speed or the high power, there's just no markings at all. I mean, it didn't touch it otherwise. I'm guessing, again, that has to do with color. I think this material just must be reflecting the majority of the energy from the laser. All right, and last but not least, this is the one that I unfortunately had to redo on the back, but that's okay. I already knew we were gonna get this result with this material. I have engraved this petg HF before. In fact, we did the 6x6 post caps here on the channel. Those were petg HF and engraved with fiber laser. And we have a good range of usable marks. Although some of these I think are actually brighter than the markings I've gotten before. I've got to get more used to doing these material tests instead of just getting a result that looks good and moving forward. Like, I think the result I was getting was probably in this range here, which isn't bad. But if we look down here, these are much brighter. I mean, that one is super bright on this material. It is almost white on this black, and that would have been, let's see, where's one with our speed settings? Yeah, so that would have been a slower speed, so it would have engraved a little bit slower, but I think it's worth it. That's exceptional contrast on that square in particular. All right, let's see if we can clean up this piece of mild steel at all. This is the face that I showed before, and looking at it closer, it's actually got some really deep gouges in it. I don't know if that end mill was really dull or what. I got this out of a scrap bin. I did not machine this, but they're really deep on this side. I don't know if the end mill was just really dull or if the work holding wasn't very good and it was chattering around. This side looks much better. Whatever process this was milled with, that's more what I would expect from the standard surface finish you'd get just from running an end mill over a piece of mild steel. So let's try and clean this side up. And again, the goal here is to just get a consistent surface finish. If we took this over to like a surface grinder, or even if we sanded this, we'd have a much more consistent surface finish. The problem with sanding is it just doesn't happen evenly. You're definitely going to take more material off of the edges than you are the center. The laser shouldn't do that. The laser should ablate an even amount of material off of this for the whole length. So let me fiddle around, see if I can find some settings that are going to work for this, and I'll bring you guys back. All right, so it's just a single pass. I just want to see what, if anything, that did to it. It's hard to tell, and I don't want to move the material. Actually, it doesn't matter. I can get the material back in the same spot. We've got an outline here on this. This, by the way, is just a scrap piece of petg that I specifically printed to put down in the bed of the machine, so that, for exactly this reason, so that when we have, call it not overspray or, but when the laser goes past the surface of whatever you're trying to work on, you don't damage the actual table of the machine. So that's what that looks like after one pass. It's definitely done something, but I can still see the pattern of the machining in there. I can't feel anything. I'm going to keep going. I think I'm going to do 5 passes at a time, and I'll check it after each 5. Okay, so after running this on the wire wheel, I can see that our tool marks are mostly still there. They are significantly reduced, probably by about 50%, so we're probably about halfway through them. Definitely looks way nicer than the unprocessed side. Some of that is just cleaning up the material, and the rest of it is, ablating some of the material away to reduce the appearance of those tool marks. Which kind of gives me another thought. We could probably use this for very precision machining. Like, let's say we got close to our final dimension in the milling machine, but we needed to, get within, I don't know, something crazy like a couple of microns on the thickness dimension. As long as you know exactly how much material is removed in a given pass, for that type of material with a laser, it's just a matter of division to figure out how many passes you need to make to get that down to the exact thickness that you want. I think what I'm going to do is I'm going to run more passes on now. I'm going to divide this section in half, maybe run a bunch more passes on just half of this, and see if we can get that to clean up even nicer. All right, and here it is after that last set of passes, and that looks pretty good. I mean, I can still maybe see faint tool marks in there just a little bit, but I mean, particularly compared to this section over here. So this is, I think there was about 30 passes here. There's about 50 or 60 passes total on the end part there. So yeah, that really cleaned that up nice. All right, I still want to try our HueForge sample, but based on the results that we got, particularly from the lighter color materials in the last test, I don't think we're going to get a good result on this. I might actually try using the diode laser on this, because I think that's more likely to just melt the material, which is what we want. All of the tests on those previous samples, by the way, were with a fiber laser. Generally with a diode laser, you don't get marking on 3D printed plastics, they just melt. But in this instance, we actually do want to try melting this. So I think I'm going to try the diode laser on this. Let me get this set up. So we'll start at 10% power, 3600 millimeters per second, and we'll just see how it looks. All right, I don't think that did much of anything at all at 10% power. I'm going to ramp up to 30% power. Let's see what that does. All right, I'm still not seeing much of a result on this. That might have softened the surface a little bit, but I'm still not seeing any melting of anything together. Let's crank this up to 70% and see what it does. All right, I don't think we can go any higher wattage than that, because that definitely caused this to soften. In fact, it's actually still kind of soft, but that kind of started to have the desired effect. It's made the whole thing glossy, and particularly the darker areas have started to melt together. So I think there's potentially promise with that, but we would have to make our backing for this a lot thicker. So what I've seen some people do with these HueForge prints is, well, first of all, they're usually larger than this, so you actually get more detail. But I've seen them basically put them on top of a thicker piece of material, whether it be, the top of like a box or even just a 3mm thick already solid printed part to give it stability. I think if we did that, we would avoid this curling effect and potentially be able to hit this with another pass or go up to either a higher wattage or slow it down. But it has picked up a really neat glossy effect. I don't know if the camera is picking that up. So I'm confident that if we kept going with this, that we actually would continue to get more of a blended finish on this. So I'm gonna have to revisit that one in the future. All right, let's try engraving the top of this R8 collet. Now, I think we're gonna have two challenges here. The first one is this is quite tall. I'm actually not even sure the head is gonna go up high enough on this machine to engrave the top of this. And secondly, we have to hold it at somewhat of an angle, like something around that to actually have a flat surface here, since this is angled back and curved a little bit. So we probably need to hold it someplace around there. I could try and fudge it in a vise, but I think what I'm going to do is measure the angle at which I have the flattest surface here on the top, and then just 3D print a little jig holder, whatever you want to call it, to hold this guy at exactly the right angle. So let me go design that, and I'll bring you guys back. All right, and that printed out pretty much perfect. There we go, and that is held at the right angle. So now the next question is, can we actually focus on this, or is this just too darn tall? All right, that actually worked. It did focus on that. So I'm not sure how much higher we could go, but it will definitely engrave that tall, and that is probably approaching 5 inches if I had to guess. All right, I just used the text tool right here in the xTool Creative Suite, and I've got this upside down because that matches how it is on the other collets. So rotated around, we would be reading this right side up, but the way that the jig is created, we actually need to engrave the text upside down. So we'll engrave that, and then I'll spin it around and we'll engrave the size on it as well, which is, I thought this was imperial. It's actually an 8mm collet. So in fact, I have two 8mm collets, but that's all right. At least I'll know I have two. All right, that looks good. Let's see if I can hold this still, but spin it around so we can engrave this size as well. I wanted to quickly mention, I like that you actually start the job from this physical big paddle button here on the controller. And I've discovered you can double tap the paddle button to rerun the job as well. So like, let's say you have 10 passes programmed in and you want to run another 10 passes. You can just double tap this quickly and it'll rerun the same 10 passes again. I also like that you have to press this to start the job the first time as well, because it's a big physical button. It's really hard to accidentally hit the wrong thing. As much as I like Lightburn and some of the other lasers I've used, it's not always intuitive that the button you're going to hit is about to actually start the job. In this case, you're doing everything in software, or at least I'm primarily doing things in software since the laptop's right here. And then as a final step, once everything's loaded, I have to tap this button to get the job started. All right, I think that, yeah, that came out really nice. Let me take this over to the wire wheel and just clean this up and see what this looks like. All right, so here's that collet after buffing that off, and that came out really nice. I mean, this basically looks like factory markings. If I handed this collet to somebody, they would never even entertain if I marked this myself or if that's just how it came brand new. So very happy with that result. And yeah, it was nice to, you guys knew I'd sneak some 3D printing into this. Making jigs for doing work like this on the laser is really, really common, particularly if you're doing repeat tasks. Like if I was marking a whole bunch of these, not only would I have this, but I would integrate this into something that actually mounted in a stationary position on the bed so that I could move from one job to another and just set this back, know that I'm in the exact right position, maybe even have like an indicator somewhere on here so that I know that I'm rotating maybe the groove in this to a set position on the jig so that I can very quickly set up without having to go back through those same steps of using the camera to align everything. All right, last but not least, let's see if we can do some very fast logo marking on the paper material for this bubble mailer and the cardboard for this box. I think we're going to be using the diode laser for this. Fiber lasers in general don't do so hot with marking on cardboard or paper, but I think the diode laser is going to do a nice job for this. And being that the diode is galvo, the same as the fiber head, we should be able to do this, I think, pretty darn fast. Let me go through the settings and see if there's any defaults for paper. We'll start there, and if I have to fine tune it, I will. All right, I imported the JPEG of my FPF logo, and I just did a trace function on it here in the xTool Creative Suite. And there's actually an option for craft paper. So I think that's what this is. I think it's craft paper. So let's just try the default settings for craft paper and see what happens. All right, that was looking really good. I stopped this though because it's taking way longer than I expected. It's made a nice mark on there. I mean, this is huge. This is a 6x9 envelope there. I mean, there's my hand for scale. So I am engraving quite a large thing. And it doesn't, you know what? It has maybe, I guess not. I was going to say it's weakened the paper, but I don't know that it really has. Maybe a little bit, yeah. I mean, it does seem a lot more prone to tearing there. So let's try some other settings on this because I was envisioning being able to do this a lot faster. All right, that's more like the result I was anticipating. That happened really fast. Now, yeah, I shrunk the size of it as well, but I doubled the power and more than doubled the speed. So I think now we're down in the range where, well, you know, this craft paper is just so thin on these envelopes. Maybe this is not the best idea trying to engrave this stuff. Yeah, it is super thin. Let's try the cardboard box. All right, that's actually pretty faint on the cardboard. Let me try decreasing the speed. I saw a fair amount of smoke. I wonder if there's a coating on this. Let's try it again. All right, got to hand it to xTool. They did actually have a default setting for corrugated cardboard, and that worked really nice. So that's a great way to kind of make it look like you're a lot bigger than you are. I mean, you know, if you get a box in the mail and it's got somebody's logo on it, you know, you assume they probably had a run of probably thousands of those boxes. But right here, pretty quickly, we were able to just, you know, create our own custom corrugated cardboard box. So happy with that as well. All right, well, we got a bunch of great results here, and let's just review what worked and what didn't. And I know there's a couple things I showed you guys that we didn't get to. This, I didn't even bother trying because based on the result that we got with the other metal stuff, I just don't think 20 watts is going to be enough power to do these battery terminals. That was a bit of a stretch to begin with, and yeah, it's just not going to do it. I think you would need realistically, based on the output I'm seeing from this machine, probably 60, maybe even 100 watts. To do terminals like this. If you guys disagree, if you have a setting or something you want me to try, let me know down in the comments. I'm willing to try it. I just, again, based on what I saw, I just don't think we have enough power output to spot weld terminals on the batteries. Also didn't bother doing anything with this aluminum disc because this piece is aluminum and we got great results on that. I don't think there's any point in messing with this further. These are both the same material. And I know I didn't get to the long board. I tried to set up the conveyor belt and it's just too heavy. I can't, it's above the weight that I should be lifting with this arm. So you'll see that at some point in time here in the future on the channel, we'll get the conveyor belt set up and try doing something longer, whether it be, you know, a piece of wood or a 3D print. I know in the future we'll be trying that out. The Collet came out really great. And this is, by the way, I mean, this is a use case I see myself revisiting regularly, is marking metal material like this, whether it be tools, parts that I have created. The ability to have professional high resolution marking on hard steel parts is going to be really nice as a capability in the shop. The HueForge print, I do want to revisit this at some point in time in the future. This guy started to warp before we really got to the power levels that was going to do blending. It already got nice and glossy and did start to melt a little bit, but yeah, the fact that it's just so thin really kind of foiled us on this one. I was disappointed in this result, but you know, I was also trying to push the machine, you know, to twice the thickness that it's rated for. And I think, you know, the silver lining is that's a great job engraving. You end up with a really, really nice dark engraving on brass, and that's gorgeous. I will definitely be doing more work on brass in the future. I'm not going to try and cut 1 millimeter thick material again like that. Even if we got there eventually, I think that would have been darn near half a day of constant running to cut through this. And there's just far better ways to make a part like this. But definitely going to revisit this for engraving on brass because that's a beautiful result just from an appearance perspective. The knife. Again, back to the marking metal. I mean, that came out really nice. That looks actually better than this knife looked, you know, when I bought it new. This had plastic logos glued onto it in this spot originally, and having that engraved like that, that looks really nice. Wusthof, if you're watching, hey, reach out. Let's see what else. Our surface finish on mild steel. I'm going to call this a partial success. We had to ablate away a fair amount of material until it really sort of turned into a nice smooth surface. I can feel a step there. We took probably 10 thou off of that till it really smoothed out. And that's because, you know, the laser is going to take off material in the ridges where that, you know, where the tool paths are from the end mill on this. So, you know, that's not really something I thought about initially. I kind of really hoped with the high frequency and just switching up the lines per inch a little bit. with each pass that we'd get a better result. It ultimately came out really nice. We just had to take off more material than I had anticipated. So if you want to reproduce this, leave yourself enough material to remove to get that nice sort of almost like sandblasted looking finish. I would leave yourself maybe 20 thou. The VIN plate is probably one of my favorites here from a functional perspective. This completely solved that problem. You know, this lasted, I think, 3 years out in the sun, and then the trailer got pressure washed once. And that label is, not only is it brittle, but, you know, clearly it was not well adhered to there. This will outlive the trailer. You know, I'll cut this here, probably just sand a little bit of a round over on the corners, drill 4 holes at the corners, and rivet this right onto that trailer. And that's where it'll be for the rest of the life of that trailer, and I won't have to worry about washing off the VIN sticker on the trailer. Our craft paper was kind of a bust. Now, to be fair, again, this is really, really thin paper. We did mark it, but it undermined the durability of the paper too much. I can't break through this craft paper. I mean, I can down here, but not as easily. Here, just barely rubbing it with my fingernail, and we're breaking through. So that didn't really work out, and it definitely marked it. It's just the material was just too thin. The cardboard box, on the other hand, that came out really nicely. The settings over here for craft paper didn't do so well, but that's not the machine's fault. Once I switched it over to the settings for corrugated cardboard, that came out pretty darn nice. Is it as dark as black ink? No, but it's probably about half as dark as if we silk screened that black. The results on the 3D prints also came out really nice as well. I had previously only tried to laser engrave black material before, black PLA, black petg, and the black petg HF. So I already knew they were all going to do well. I'll admit, my settings were not as optimized as the settings that ended up, sort of coming out of this material test. And, again, that's why you do material tests to make sure you are on the optimal settings. The contrast of these settings down here on this material are far better than what I was using. So I'll be updating my settings for marking on 3D prints to these settings here, which looks like about 18% power, 2,000 millimeters per second. And this is a 20-watt fiber laser if you're trying to convert that into settings for your machine. The results that we got on this silk shiny copper, again, are just, I'm probably going to play with this more. I mean, we really kind of have almost several different colors there. There's almost even like a green tint to some of these when I tip it sideways. Like that's really cool. I'm going to be messing more with this, and in fact, I might even order some more silk shiny filaments just to kind of see what results I can get on it. But probably the most surprising one was the shiny, almost painted look that we got on this gray PLA. Like that is next level. It doesn't even look 3D printed anymore. It had enough heat in it that it sort of removed the layer lines, and instead you just have a smooth, I can't, you hear me scratching that with my fingernail, and I'm not touching it. If anything, I made that spot a little bit shinier. Like that is a really nice mark on there. So would I recommend this machine? Because I get that question all the time down in the comments, anytime I bring a new toy into the shop. And yes, I would. I think this is a great fit, particularly for people that are maybe ready to move on to their first real laser. Maybe you've gotten one of the, $300 or $500, gantry style diode lasers. That's very slow and very limited in what you can do with it because it's only a diode laser, and you're ready to move up to a real machine that's going to bring a lot more capabilities to your makerspace or your shop, wherever this is going to live. And I think it's a great machine for that because it's got 2 lasers in the head. Again, you don't have to choose between a galvo diode laser or a galvo fiber. It's both. And probably the most important feature to me is safety. It's really refreshing to see the approach that xTool took with this machine with safety. Between having the lid that comes down and completely covers the work area, and yeah, you can disable the sensor if you have to. If you have a large piece of material here, you can disable it, and that's how I got the videos that we shot with this cover open. I just disabled the safety sensor. But if you keep that enabled, this machine isn't even going to turn on if that cover is open. And should you forget that the machine is running and open the cover, it stops immediately. The dust extraction port on the back or the fume extraction port on the back, you can route that outside as is, or if you pick up the fume extractor, it'll connect directly to that. Or maybe you've already got a fume extractor. You can connect it into your existing fume extractor. You don't need to use theirs. It uses standard couplings for this size. I like the fact that it's got the control panel. I don't see myself coming back and rerunning jobs from just the panel that often, but I don't do that type of production work. If you have 4 or 5 jobs that you frequently do, I can see using the panel for that. But I do really like it, if for nothing else, that you have that physical button to start jobs. There wasn't a single instance in which I accidentally started this laser. And yeah, I've totally done that with other machines that are just software, and you either accidentally click the wrong button or you click start thinking there's still one more step. No, it's really apparent with this when you push that green paddle that you are starting the job. This machine also checks a lot of other boxes as well from just a convenience and usability perspective. Having the autofocus where it raises and lowers the head to find the exact correct distance over whatever you're engraving is super nice. And the camera, I kind of thought that was an unnecessary feature on a laser that will do a framing. That turns out I was wrong. I used the camera a whole bunch on this machine to scale and position artwork. Could I have done it with just a framing function on another laser? Yeah, I could have, but I was able to do it twice as fast because I could preview the part and just line it up wherever I wanted. That camera feature is really, really nice. I think the only thing that might be holding this machine back a little bit is the software. And don't get me wrong, the software is very good and it is incredibly easy to use, particularly for beginners, because it's as easy as just picking the material that you want to work with, selecting your artwork, and you pretty much hit go. It does everything else for you. However, if you're someone that likes to really tweak a lot of different settings, you might be left a little bit wanting with the xTool software that's included with this machine. The good news is this machine does also work with Lightburn, and Lightburn has a tremendous amount of configurability and settings in comparison to the xTool Creative Suite. Now, the flip side of that is Lightburn it's a steep learning curve. It's not as easy or one touch as the software that's included with this. But hey, I mean, that's the other end of the spectrum. You're probably going to start with the xTool Creative Suite, and if you ever find yourself outgrowing that, you can always just pick up a copy of Lightburn and configure this machine in Lightburn, and it will work just fine. So if you're in the market for a laser cutter engraver, definitely check out the xTool F1 Ultra, especially if you're looking for either a galvo fiber or a galvo diode, or if you're looking for both. I mean, this machine checks both those boxes in one machine in a pretty small footprint, which is really nice rather than having to carve up space in your shop for 2 different machines. This one gives you both under one cover. And of course, this is a great time of the year to be buying this type of equipment. If you're watching this video anywhere near the time that it came out, xTool has some awesome deals for Black Friday, and I'll put that information down in the description of this video. And I do want to mention the link down in the description for this machine will be an affiliate link. That means if you click my link here in the description of this video to buy this, I earn a couple bucks. And if you don't feel like I earn that, just go right up to xTool's website and search for the F1 Ultra. You don't have to click my link. The cost to you for the machine is exactly the same whether you click my link or go up to their website and search for the machine. I just put that link there so that people can use it as a thank you if I helped you make a decision on this machine. Guys, thanks for hanging out in the shop with me for this week's video. And if this is by chance your first time here on the channel, this is a functional printing channel. Every Friday, I release a new video where I do some sort of functional design, like this guy here. Typically it's a lot more complex than just a simple jig for an R8 tool, but that's what we cover here. It's all functional printing. I give away all the STLs for free. So if you enjoy watching me, make stuff, fix stuff, and you're into the functional side of 3D printing, check out some of the other videos on the channel. And if you like what you see, hit the subscribe button. And guys, if you do, I'll see you next Friday.